without taking any more time, we have Corey Cooper from Circle, and Corey will be presenting building better payment experiences with USDC and CCTP. So over to you.
So I like to start my presentations off by explaining to people where I'm from. So I'm from Atlanta, Georgia. It's a great city. It's home of one of the most iconic brands, Coca-Cola. It hosted the 1996 Olympics, which was pretty big, and birthplace of Martin Luther King, who was a civil rights leader who changed a lot of the human rights around the world. And I feel like these things that happened in Atlanta were innovations that happened in a city that grew its economy. And I feel like now with blockchain technology and a lot of the stuff that you all are building is changing commerce around the world. So it's super innovative. It's not only going to help and change things that happen in a city or a state, it's going to transcend and change things globally. So I'll talk about the topic and what went into this, topic of building better payment systems with CCTP and USDC. Circle is the sole issuer and creator of USDC. And what we wanted to do is build payment infrastructure that was future-proof and native to the internet. And so with CCTP, we wanted to make sure the payment rails that we were building on public blockchains were interoperable, and we didn't reinvent old traditional payment rails where you have networks like Visa and MasterCard and Amex that can't do interoperable payments. If I'm from America, I have an Amex, I come out here, I want to use my card to make a payment. Usually they say we only accept Visa. I can't make that transaction. So we don't want to bring that into Web3. We want to make sure things are interoperable and these ledger systems are able to work across chains. And so that's what we're bringing kind of to the table with the innovation of cross-chain transfer protocol and USDC. So here are some of the topics that I'll go through. This is a kind of walkthrough of the agenda. We'll talk about what CCTP is, why we built it, and then a high-level overview of the smart contract set. And then we'll do a deeper dive into the functions that are built into the smart contract that actually facilitate these transactions cross-chain. And then we'll talk about integration, and then we'll do a demo of a developer ecosystem partnership we have with Third Web, where we kind of show developers how to, make their first testnet cross-chain transfer protocol, running the script and using Third Web's SDK. So, what is CCTP? It is a permissionless on-chain utility that allows for developers to natively move USDC from one blockchain network to another. Right now, we have 3 supported routes. They're bidirectional, so someone can use CCTP with Ethereum, Arbitrum, and Avalanche. So that's 6 different routes, basically, in a bidirectional way that USDC can be natively moved across in a burn and mint methodology that is a little bit different than most bridge companies, where you kind of lock up capital and then issue a wrapped version on a native chain. So, like I said, it's an on-chain utility. That on-chain utility are a set of smart contracts that we deploy on the supported chains that we support USDC on. So we have a set of smart contracts that facilitate the burning and minting on the source and destination chain when you are moving USDC across chain. So why did we build this? So first thing is we wanted to make sure that people were using native USDC. That was the goal when we built USDC, and now we've recently launched EuroCoin. We want users to interact with the native versions of the tokens that we issue on chain because they come with compatibility features of on and off ramps between fiat and stablecoin. These wrapped assets, and derivatives of USDC don't have that functionality. And so there's a lot of risk there when you deal with them. We also want to unify the liquidity. So what that means is basically we wanted to make sure USDC on Ethereum was the same thing as USDC on Arbitrum. So the liquidity is universal and developers can freely create these automations or cross-chain transactions where they're moving liquidity across chain and it's one-to-one. So you don't look at maybe Ethereum on Solana less than you would look at Ethereum on USDC on Ethereum. So we wanted to make sure the liquidity was unified across chain. And then fast transfers. So with this, there are some bridges, that transfers can take sometimes up to a week. And so that kind of makes it feel like it's a traditional banking transaction. And so we want to make sure these transactions are pretty fast. And so we're able to do that with the smart contract set of, burning a token out of circulation on a source chain and minting that on a destination chain. And that usually can happen in a matter of minutes. I would say right now with the routes that we have right now, the longest time you'd wait is probably like 10 to 15 minutes for that burn and mint activity to actually happen in totality. So we're able to offer faster transfers across chain. Interoperability, obviously I used that word earlier. This is really important because we want to make sure that people can create unique payment experiences where there can be cross-chain transactions. And we can also, create experiences too where you can use USDC as a conduit to moving some other fungible token across chain. But the interoperability is really important for developers to build basically applications that, aren't stuck in a one network on one blockchain. They can use CCTP as a way to open up their total addressable market to other USDC holders on other chains. And so also the many-to-many relationship was a huge factor in the design. So we wanted to make sure the routes, were bi-directional. So if we have CCTP smart contract sets on Ethereum and Arbitrum, those transactions could go back and forth. So it's not just Ethereum to Arbitrum, it's Arbitrum to Ethereum as well. So we wanted to make sure all of these routes were many-to-many. And, if someone wanted to move, Avalanche, USDC to Arbitrum, they could go directly. They wouldn't have to go a hop through Ethereum. And then the extensibility is where like the real creativity comes for developers. So it just doesn't stop with USDC being transferred, across chain. You can also, leverage some of the other parameters in our functions for calling subsequent, contract addresses. So think if, a scenario where maybe you wanted to transfer USDC across chain, and when it hits the destination chain, it may call a smart contract to call a DEX to swap that to the native token of that chain. So giving you the ability to build composable contracts on top of it and just creating stuff that we never thought was imaginable. So I'll give you a high-level overview of the architecture of it. So in a nutshell, CCTP is basically general messaging system with signatures. And so basically allows an event to happen on a source chain. Then we have an off-chain attestation layer, which is our Iris API that observes that that event actually happened on the source chain. So burning activity actually happened. And it allows you to call that and fetch basically a signed attestation that you then can take to your destination chain and call, the CCTP contracts there to receive the USDC that is minted to the address that you wanted to actually move liquidity to. So, there it's basically just like a block explorer with keys when you look at it from a 5,000-foot view. So let's walk through these steps, of the different functions that would be called in the actual smart contracts that you would use if you wanted to move liquidity across chain. So first, a user would basically call a approve function in the USDC token contract, and basically they would specify the amount that they want to interact with our smart contracts at. And that's the token messenger contract. So they would say, hey, I want to send $10 of USDC, across chain using CCTP. They, specify that amount in the approve function and sign that message. And then they are now interacting with the token messenger contract, and they pass a few parameters in that to actually initiate the deposit for burning that USDC out of circulation. And after that activity happens, a message is constructed and sent to the message transmitter contract on the source chain that basically says, hey, this burn activity happened for this amount, and it emits a message from that contract. There's message bytes, and then you take that emitted message byte and you hash it, and then you send it to fetch that attestation from our off-chain API, the Iris API. And so calling that, it'll respond back with the actual signed attestation that you can then pass into the receive function on the message transmitter contract on the destination chain. And that will trigger the minting of freshly new USDC on the destination chain. So I will jump into the smart contracts. So this is the message transmitter smart contract. So basically it's a messaging layer that sends and receives messages about the burning, minting activity that's happening when CCTP is actually in process. And so it also maintains nonces so that no replay can happen, where someone can actually falsify and create more burning and minting activity than actually that's actually happened or whatever. So make sure it protects from any type of replays. And so as you can see, you've got your send message where it's basically constructing that message of the destination domain. So that's the blockchain, that CCTP is you're sending to, and then you have your recipient, which is a byte 32 version of your blockchain address, and then you have your message body. And so if you use the send message with caller, what you can do is you can actually specify a address that you want to be able to call on the destination chain. So you can make sure you can be specific and say, I only want this address to be called. So that will make sure that on the destination chain, this address is the only address that actually can trigger the actual minting of USDC on the destination chain. And then you have your token messenger contract. So this is basically designed to handle the minting and burning of USDC. So it basically takes on the destination chain, well, on the source chain, it'll take the amount that you want to burn out of circulation and start interacting with our fiat token contract to initiate that burn. And then on the minting side, it receives that from the message transmitter contract to actually tell it to mint whatever USDC was the specified amount that needed to be minted on the actual destination chain. So here's a diagram of kind of the flow of how all of this works. So user basically interacts with approval on the token contract, and then they actually specify the amount they want to burn, the destination domain, which is the blockchain that they want to send USDC to, and then the mint recipient, the person who is to receive the newly minted USDC, and then the burn contract, which is the actual USDC token contract. And so it'll come in, it'll go down to the token minter contract, and then that actually burns the amount of USDC out of circulation. And then you'll go up to the message transmitter, and it will emit a message, basically, of that burn activity happening. And then you take the actual message and hash it, and then call the off-chain API service, and then pass that response of that signature into the actual received message with the unhashed version of the message bytes that was emitted in the source domain burn column, right? And then it'll handle that message and actually pass it down to the token minter contract and ultimately mint the freshly new USDC on the destination chain. Okay. So now I'll do a technical walkthrough of a script that you all can run to actually run something on testnet and kind of see the functions that are called and play around with actually moving USDC natively across chain. So ThirdWeb is our developer ecosystem partner. So if you guys want to scan this, it'll take this directly to the repo that I'm using to actually perform this actual transaction. So let me move over here to the computer and actually share my screen to run through the transaction. This code base is basically a script that you can run. At the top, it shows you that we've worked with ThirdWeb, and so they've created basically an SDK that you can import. This SDK from ThirdWeb will allow you to interact with the smart contract set that facilitates USDC across chain. It also is using Ether's JS library to make method calls against the smart contract set. And there's a few things you want to set before you actually run this script. The first thing is you want to go to your environment variables, and this is a throwaway wallet, so that's why I'm showing the private key, but you would want to put your private key in, and that will be a wallet that you have access to. This private key should have access to both the wallet address on the actual source chain and destination chain. And after you set that key in here, then you can go to the index.ts file, and you can actually first set the amount of USDC that you want to transfer in line 10 right here. And then this is where you define the source chain and the actual destination chain. So here's where you would configure the testnet contracts. So in our developer docs, we list out the different contract addresses that make up the CCTP protocol. So you configure the contract addresses here, and then you'd run the script, and it'll run through these steps of approving the actual USDC to interact with the token messenger contract address, and then burning the USDC, ultimately receiving the message bytes from the logs, hashing that message right here in line 99, and then fetching that, calling the actual off-chain API to actually fetch the attestation. And then you would receive the attestation, and we'd obtain the signature here, and then you'd call the actual receive message function on the destination chain, and then it would actually trigger the minting, and then we'd get an actual transaction hash that we could look up on the block explorer to verify that activity had just happened. So I'll run through this script live. Well, actually, let's look at the wallet addresses first, so you guys can kind of see the amount. So we're going to go from Ethereum to Arbitrum. So I'm going to go to Gurley testnet. Okay. So I'm going to send $5 to USDC. Right now I have $157 on my Gurley testnet, and then we're going to send it over to Arbitrum. So I've got 285. So I should end up with $290 of USDC on my Arbitrum account. So let's go back to Visual Studio. Let's see, and let's run the script. So it's now interacting with the wallet address and approving the amount of USDC that we want to interact with the actual token messenger contract. Taking a little time. So it's approved that amount of USDC that we'd allow to interact with the token messenger contract. So it's given that transaction hash of that approval. Now it's depositing the USDC in the actual token messenger contract, which initiates the burn activity. And burn activity has happened. We've got our transaction hash right here of that burn activity happening. Now we're fetching the sign attestation from our off-chain API. Takes a little time. All right, so we've obtained the actual signature, and now we're taking that signature and the message bytes, and we're passing it through the receive message function on the destination chain of the message transmitter contract, and then it actually minted the new USDC on Arbitrum Gurley. So let's go pull up this transaction hash on the Block Explorer. Okay. All right. So let's put this in. Let's search. All right. So you can see here, right, that $5 of USDC was minted to that address. And let me pull up my wallet and see I've got $290 now in this Arbitrum wallet. Went from $285 to $290, so successfully went through. And so this is, pretty powerful because now you're able to safely move USDC across chain without having to worry about, your USDC being locked up in a escrow contract, and then you're issued a wrapped version of it, and then there's a hack, and you can't kind of go back because your core asset, that is backing the wrapped asset is gone. And so we feel like CCTP is a great way to allow for bridges to integrate and create basically an enhanced secure version of moving liquidity across chain. But also we think that there is a lot of opportunity for developers to build very cool wallet experiences and payment experiences, with the ability to kind of do cross-chain transactions. So thank you all for taking the time to listen to me talk about this. I guess now we can